Hey everybody, I'm Zach the Welder, and thanks for tuning in for another video. So this week we're doing some big sanitary tubing. So basically what we're doing here is we're taking some 10-foot spools of this and we're adding a tank spud. And if you don't know what a tank spud is, allow me to fill you in here. So this looks just like a standard 4-inch ferrule, except it's bigger. Mounts up to a standard 4-inch ferrule. The ID is going to match up to your 4-inch sanitary tubing. The OD on this part is larger, so this is meant to go inside a tank and give you something heavy to weld to. The wall on this is probably close to 1/4 of an inch, so it's really nice. You don't have to purge the inside of this when you're welding on a tank. You can just weld it on there. Unless you really get crazy with a torch there, you're not going to burn or roach the inside of this. In addition to our tank spuds, we're welding some 8-inch ferrules on this. So yeah, again, if you are in the sanitary world, most people have never dealt with a ferrule this large before. Usually, like I said, 4 inches is as big as you're ever going to come into contact with. So this stuff you have to treat more like Schedule 10 stainless pipe when you weld it. So typically your 1.5 inch or your smaller bore all the way up to 4-inch, you are not going to put a bevel on. You are just going to butt your two pieces together, and then you're going to run your TIG torch around and you're going to fuse it. You use a purge on the inside to balance the size of your puddle. And now I'm going to do more videos on this, but basically you have gas on the inside of the puddle here pushing out. So as you weld it, your weld puddle will be slightly bowed out, and then as it cools, it will cool down and become flat. There's a little bit of an art to it, but we'll do some more videos on that. But this stuff, you weld differently. You weld this more like pipe. You actually put a bevel on the end of this. I just go with a knife edge. Makes it a little easier to burn in on these ferrules, because the ferrules I'm not going to put a knife edge on. I'm just going to do it on this. We'll put it up against here. We'll use a standard pipe clamp like you would if you were just welding pipe. Tack it, and then we'll go ahead and use a purge cap that I actually made and a standard purge dam. I'll show you this here in a bit. And we'll go ahead and we'll weld it out similar to what you would Schedule 10. So we'll go ahead and put a root pass in with no filler to make sure we totally burn in. Then we'll go ahead and we'll put in a cover pass with a 332 rod. All right, so the first thing we got to do here is we got to break our 20-foot stick of tubing into two 10-foot pieces so we can weld our ferrules and our tank spuds on. So the way we're going to do that is we're going to use this exact pipe cut saw here. They make an orbital tubing saw that's big enough for these, but you're looking at a $12,000 saw versus I got this guy off eBay for 1,800 bucks. It's still a very expensive saw, and it uses these blades that are $165 a piece. So your cost per cut is a lot. Like, you'll get maybe 4 cuts out of one of these blades before it's junk. I've tried getting them sharpened. They don't really work that great. So yeah, you're looking at $165 over 4 cuts. So this is a very expensive game to play. first things first here, I got this Sumner pipe clamp on here, and then the nice thing about this is it squeezes the tubing, and then you've got 3 adjuster points there with those thumb screws that you can go ahead and put this in here and use the thumb screws to go ahead and get rid of any high-low. And then also, if the tubing is a little out around, you can go ahead and use the clamp itself to kind of squeeze the tubing there to get rid of any step or high-low, to where you have a nice smooth interior to the pipe there. Now the next thing we're going to do is we're going to use one of these guys here. This is a purge dam, if you've never seen one of these. I forget the name of the company that makes these, but you hook argon up here and then these guys inflate and it will seal off the pipe. Now this is meant for welding a joint here where, whoops, this thing came apart. This is meant for welding a joint where you would have the joint in between here and then it purges in here. But what we're doing here is we are using this cap that I made to go ahead and butt up against that ferrule. Now this is really thick here, so in addition to acting as a dam for the argon, it also acts to pull the heat out of the ferrule, so you don't get any distortion or any weirdness like that. So it's really nice for that, where it just, you know, clamps onto it and acts as a big heat sink. And then I also have a port in here with just an air fitting, so we can go ahead and purge the inside of this with argon out. And we're gonna go ahead and purge that before we start welding on this. All right, so I just have argon hooked up to this 1/4-inch poly line, and it doesn't take too long for these bags to inflate. So we'll just go ahead and stick them up in there. I think about there is close, and seal off the pipe. All right, so we're gonna go ahead and tack on our ferrule here. So I've got everything all lined up. I've got argon flowing through my purge cap here. We're gonna use Miller XMT 350 back here. It's set at about 85 amps. So we're just gonna go ahead and light up and see if we can get a few tacks on this guy here. So that being said, here we go. We'll touch off. Come on, jump the gap, jump the gap, jump the gap. I'm gonna have to use a little bit of filler. It's wanting to burn back away, so no big deal. We'll just dab it with a little bit of filler here, just to get it going. And then once you get it going, it'll wash in, but you just need a little bit of extra help just to get it going here. So touch off right there, boom. Now, as that tack wants to cool, it'll want to pull the ferrule that way. So we'll go ahead, check it on this side, get a tack over here. Just need a dab, little tiny bit of filler. You don't need much. Let that cool for a second. Now, these are on some roller stands, so we can go ahead and, oops, that's what you got to watch out with right there, is because these spring clamps will want to move on you. So we'll go ahead and get a tack on the bottom here. Flip out, same thing here. We'll get a tack on there. Okay, so now we can go ahead, pull our clamp off and get a few more tacks on here. Okay, so we got enough tacks on here. Now we can just go ahead and put our root pass in.
So just for the ease of filming this, I went ahead and did this freehand. You'd probably have a lot easier time walking the cup, doing the root pass here. It's a lot easier to just be able to set the camera up on a tripod and rotate the pipe and keep the torch in one spot to film it. So that's why I did it this way. You basically just want to go slow here and just give it time to melt all the way through to the inside. Now that big aluminum plate there will pull a lot of heat out of that ferrule. Like it's really surprising just how hot that piece of aluminum will get. Like it pulls all the heat out, so you have to spend a little more time on the ferrule side of the weld there than you do on the bevel side to make sure you get that wall broken down on the inside. Now, one little tip here for keeping a consistent travel speed on this is you can either use a metronome app on your phone, which is kind of boring, or I like to have music going where the BPM or the beats per minute is about 120. That seems to work for me. But you really need to find something with kind of a consistent tempo like that where you can just kind of keep your timing speed going fairly consistently. Battle of Los Angeles by Rage Against the Machine is like the perfect thing for me right there. Now I have somewhat of a confession here to make. I am not the best pipe welder out there. I know that's going to be a shocker to a lot of you. Hopefully you can tell there's sarcasm there. But this is something you really have to do every day to be really, really good at it and, stay really good. And it is definitely a skill that has a lifespan. Just with the type work I do, there's, projects like this where by the end of it, I'll have a really, really good looking pipe weld like that. And then I might not touch it again for 6 months. And then it takes some time to kind of get back in the groove. Guys that do that all day, every day, my hat is off to you. You can produce some amazing looking work, but unless you're doing that every day, you just can't really keep up that level of proficiency. But it turns out decent, and one nice thing about this is you can just wash back over it without filler and make a really, really nice looking weld, and nobody can tell the difference. So here I'm running about 85 amps, and I'm just trying to keep my travel speed going. One thing with stainless like this, you really just cannot rush it. You just have to kind of go at the speed it wants to go.
All right, so we have gone ahead, we have welded our ferrules on our 8-inch tubing here, and now we've got to make some holes for our tank spuds. So as I said earlier in the video, I was putting some of these tank spuds in here. These are a clean out, so basically a powder flows through this tube under vacuum and pulls the product through there. We need to put some of these in here every so often to where if it does clog up, they can just pop a cap off here, blow compressed air in there, loosen the product and get it to flow. So this is a tank spud. This is a 4-inch tri-clamp ferrule with a heavy wall. So what you'd normally use these for is if you're putting a port in a vessel, you cut a hole in there, stick this in there, weld around it. And the reason the wall is so thick on that is so you can weld it without having to purge this, or without, when you do purge it, kind of pulling back and leaving a void there. So these are really handy, and we're gonna go ahead and cut one in here. So you can just use a hole saw, like the Milwaukee ones seem to last the longest that I've found when you're cutting this kind of stuff in. With a hand drill, it is not fun to use a cordless drill to cut these guys in here. It takes a long time and is a major pain in the butt. So if you have access to one of these rigid HC 450s, or they have a smaller one that I don't remember the model of, I looked around and watched eBay for 2 or 3 years before I was able to get a deal on these. If you just go out and buy one of these, they're stupidly expensive. I think I gave like 500 bucks for this one. So if you got the option, use one of these. Really cool. So basically it is a drill press that clamps onto any size pipe, and much less sketchy than just using a hand drill, and it doesn't walk all over. So we're gonna go ahead and pop a hole in this guy here, and I'll show you fitting up this. So what we'll have to do is we'll kind of have to elongate that hole a bit to get this in at a 20-degree angle, and we'll have to just take a Sharpie, mark this guy, use the plasma cutter to cut it close, and then we'll go ahead and use a flap wheel to get it exactly where we want it. All right, so now we've made our hole. Now we got to go ahead and fit this guy in here. So as you can see there, doesn't fit. So what we're gonna do is I got one of these little Klein digital angle finder dealies here. And so I'm just gonna hold this guy at about 18, so we want it to be about 20 degrees. So I'm gonna leave that over here for you to see. So we're gonna be about here. So there's 22, 19. So we're gonna be real close to right there. So 4 1/4 inch OD on that hole saw leaves me pretty close to where this guy will fit in here. So what we'll do is we need to pull a little bit out of here with a die grinder, and we need to go ahead and knock some out of here. And then if we take, I don't know if you're going to be able to see that, but there's a little bit of a gap right here and a little bit of a gap right there on this side. So that if we knock a little bit out here with a die grinder, this whole thing will shift this way, and we can just go ahead and take and use a die grinder and fit up over here. So yeah, now we'll just go ahead, now that we got it marked, take a die grinder with a carbide burr in it and just make this guy fit. Take this guy, set it on there, see if you got a good fit. Set her right there. Okay. Looks pretty good right there. can live with that. I think that'll work out pretty well. All right, so we're ready to go ahead, seal this up, purge it, and then go ahead and weld this clean out on here. Now, if you use a large cup and are quick with your tacks on this, you don't need to worry about purging it before you tack it. So you just got to be quick and kind of know what you're doing. I'm using a cookie here from purgeplugs.com to go ahead and seal this 4-inch port up. And I've got my inflatable purge dam in here, kind of about here in the pipe, just so we don't cook it. And then this is the purge cap that I made. We'll go ahead, clamp it on here, get the gas flowing, and purge this guy out. Okay, so we're gonna go ahead and start welding this guy out here. I am using 1/8-inch filler, and we're gonna run about 80 amps here. What I wanna do is just kind of wash this over here without taking any chance on sugaring the backside. I've got a purge in here, but I want this to be where I can buff it out and it can be perfect. So I don't really want to put a whole lot of heat into it and burn through to the inside. This is not under any kind of pressure. This is going to be under vacuum in the process it's in. So I'm not too worried about it being structurally sound. I want a nice, clean, sanitary weld. You'll find that in most sanitary work, you're not really going for absolute strength and structure. You're just going for 0 pits, 0 porosity, 0 places for bacteria to build up, and you want to be able to just wipe it and clean it. So we're going to go ahead, light up here, and start welding this guy out. What I'm doing here is I am just kind of washing over this piece of 1/8 inch just to kind of fill in any gaps and get a nice smooth weld. Like I said, this is under vacuum and it is not under any kind of positive pressure. So really, I'm not worried about structural or strength. I'm just worried about any kind of pitting, porosity, you know, any of the stuff that might be able to harbor bacteria. Now I switch sides here so I don't pull one way or the other. Stainless moves a lot as it cools. So I'm going to try and bounce around here. Do a little bit of weld here. Move over to the other side, do a little bit of weld just to minimize my movement. And that's just kind of something that comes with experience from just, you know, making mistakes on projects basically. So I'm running about 50 CFH of argon inside the pipe here to keep a nice purge and positive pressure of argon moving out that hole there. So I want to minimize the amount of, minimize the chances of any oxygen getting in there. So now I'm going to bump over here to this side and try and get a few inches of weld here. And again, you know, this is not rocket science. I'm just washing over this, trying to not put a whole lot of heat into the part. I will probably wash back over it with no filler, just so I can get a super smooth weld. Which that's pretty common in the sanitary world there, to just wash back over a weld that had filler, just so you have 0 edges. Just make it as smooth and as clean as possible. Because really, I mean, we do not care about strength with this. Like I said, this is going to be under vacuum, so it really does not matter so long as it is a clean and polishable weld. So we're running, like I said, about 80 amps on that XMT 350 there. Those Field Pros, the newer ones there that have the arc reach deal, are super smooth. They have just a really nice TIG arc that I really like for this kind of stuff. You can really use just about any kind of TIG power source you want, but those are especially nice as they light off really well and don't contaminate your tungsten. All right, there we go. We joined up to that other weld. Just keep the gas on it there for a minute. We'll go ahead and move to another spot here as we work around to seal that up. And I'm in the rolly chair here, trying not to roll over my argon purge or my TIG torch. So we'll go ahead, light up here and see if we can go ahead and wash this side in. I'm using a CK Flex neck water-cooled torch. I really like that setup on that XMT 350 because you can weld up to, I believe it's 350 amps on this torch continuous duty, and I've done it on some really thick wall stainless parts I've had out here. It was, I believe, 1.5 wall, and I just had to do pass after pass after pass on that thing to get it filled up. All right, so now we're from here all the way to here. We're just going to work around the back side. And again, I am just trying to wash this in. I'm not trying to, not trying to burn it in really hot, because I'm going from a 1/4 inch wall on that tank spud to 108 or 109 wall on this tubing. So I don't really want to put a whole lot of heat in it. That's why I'm using that 1/8 inch filler as kind of a chill, to where I can just kind of wash it in there and not dump a whole lot of heat into the tubing itself. So I'm kind of favoring, that tank spud. And I'm going to have to adjust my tungsten out on the back side of this guy here. So let me whip out. So I got that at an angle. I'm going to have to extend my tungsten out just a smidge here, so I got enough reach to get into that corner. And once again, with a water-cooled torch like this, your tungsten stays nice and cool, so you can adjust it with your fingers real easily. So now I got a pretty good stick out there. I can get in that back corner and I can go ahead and work my way all the way around. I think what I'll do is I'll come in from this side, so I got a little bit better view of it. And we'll just go ahead and wash this guy in. Whoops. Alright, there we go. Get it hot, and then add your filler. And start washing it in. Some more critical applications, I would probably use a pair of snippers and snip off the oxidized edge of my filler, or end of my filler, not the edge of my filler. But with this one, again, I know where it's going. I know what the customer expects, so I am not super worried. That is one nice thing about having really good communications with the end user, is because you know exactly what they need and what they expect. Not that you want to, ever do substandard work, but there's times where they don't want to spend the money on absolute perfection. And if you are able to have a good communication with them, you can tailor your work and your quotes to their expectations and budget. All right, there we go. We walked our way around there. Now we'll go ahead, put another pass around it here, probably with a 16th filler, just to kind of wash it in and make it look all nice and pretty. Then we'll go ahead, flip it, clean up the inside, and we're all good. All right, so I keep a little air drill here. This is like a 5,000 RPM air drill with a stainless wire brush in it, just for polishing up welds like that in between passes. All right, I'm gonna show you all a little gadget here that if you're a TIG welder is gonna make your life a whole lot easier. This is the Sharpie tungsten grinder. It's just a Milwaukee die grinder body, and we're gonna sharpen the tungsten here. So right there, slip it in there, flip it, and you can do both sides just that fast. I absolutely love this guy. For the longest time, I refused to buy one of these and always would use a grinder with a flap wheel in it. And I was like, it's good enough, but you gotta hold it down there, use your fingers. You can put it in a drill and kind of do these numbers. But I tell you what, this was like 350 bucks. You get your fingers into a flap wheel, how much is that hospital bill gonna be? A whole lot more than 350 bucks. So that's why I bought one of these. And it does a great job every time. This just lives in my toolbox now. So anyway, hope you guys enjoyed this quick tip. All right, so now that that's cooled off, we're gonna go ahead and put in our last pass here. So we'll just light up. Get a good bit of heat going in there, start adding some filler. And we'll go ahead and just wash this guy in. Now you could definitely walk the cup on this. I am not, but you definitely could. Yeah, we're running 80 amps and just kind of slowly going along here. That is one thing with stainless, is just don't get in a big hurry. You can add more heat, but generally that just adds more distortion and causes you more problems down the road. So yeah, just go slow. Whoops. And I jiggled and dipped my tungsten there, but fortunately, again, if you let it cool for just a second, and you can't get away with this on every power source, but that XMT350 will kind of just chill out for a minute, cool, and then you can go ahead and just kind of pop it out like that, and you still have a decent tip on your tungsten, but not every power source lets you do that. Alright, so yeah, I'm getting a little shaky here. I need to go grab some lunch, which is perfect because we'll let this guy cool and then do the ID of the pipe. All right, so if you stuck around till this point in the video, I hope you guys actually got something out of this. I kind of wanted to detail how you would go about a project like this. I know this is kind of a larger project than most people get a chance to tackle. There's not a whole lot of 8-inch sanitary tubing out there. Most of it's going to be your 1.5 to 4 inch. So I just kind of wanted to show you how you would, what techniques you would use to go ahead and tackle a project like that. So anyway, I hope you guys enjoyed this video. Please drop a comment below if you did, and thank you all for watching. Once again, I'm Zach, Darlington Farm. My business is Hoosier Stainless. Thank you all for watching.